Welcome to this fifth video in the series about Elastic Services e-commerce accelerator called PRISM. PRISM stands for Policy, Rules, and Intent Synthesis Middleware. In this video, you'll learn how PRISM implements user purchase history boosting to ensure that each user sees personalized and relevant results. So if somebody searches for bread, and up in the top right corner here, I can just set this to no user being logged in. They might see results like this. So we do our best to provide relevant results that match the intent of their search, but we don't know anything about the user. In the previous video, I showed how we can use cohort boosting to boost up products for certain cohorts, such as show halal breads to halal users looking for bread, or show vegan breads to a vegan user, or show kosher bread to a kosher user. But we're talking about something different in this video. What I'm talking about now is how we can boost up the products that user has purchased in the past. So if I switch this user to a user called Alice, we can see that she has purchased crushed sourdough bread and whole wheat bread. And you can see it's already changed in the background. Right now, crushed sourdough bread and whole wheat bread are the top two hits. So how did that happen? Well, we've taken into account her purchasing history, and we've seen that this particular bread was purchased, therefore it should be boosted up. And there's a whole calculation here that's covered in detail in a blog post that I'll link to at the end of this video. But effectively, we are taking the base multiplier, we're taking into account margin and popularity, which I'm not talking about in this video, and then we're multiplying by a boost based on the purchasing history of this user. Same thing for this other purchase. Now, this particular product only has a boost of 1.47. Why was this 2? Well, if we go up here and we look, this is calculated based on the quantity. So how many of a given purchase and when was it purchased? So this was purchased a lot of times, even though it was 35 days ago, it gets a boost of 2, which is the maximum that we've configured. This whole wheat bread was only purchased once. It was purchased today, but it gets less of a boost because she has shown less of a preference for whole wheat bread. Again, if I was to turn off or to not be logged in, the results would have looked like this. So how does this work? Well, remember, the architecture of PRISM it's a middleware. It sits beside a retailer's application server. So effectively, a user search comes into the application server. It's redirected into the PRISM engine. And what we've previously talked about was happening over here, the policies that are applied to interpret a query. But now what I'm talking about is what's happening on the right side. And this happens in parallel. Effectively, the user purchasing history is checked. Has that user purchased anything related to, in this case, bread? And if so, well, let's return that. Then the PRISM engine will create a rewritten query that has boosts for the particular bread that user, or the breads that user has purchased in the past. The rewritten query is returned to the application server, and that is then executed against a product catalog. And at that point, the user will receive personalized results. So if a user were to, just as another example, we can show if they were to search for steak, again, no user up here in the top right. But if this were a user, Tanya, who had purchased steak, you can see that immediately British Sirloin Steak and the organic British beef fillet steak were boosted up to the top of the results. And that's because she purchased them in the past. Again, if we were not logged in, a search for steak might return results that look like this. So how does this look? If you look up here, you can see that, in fact, debug is enabled. You can also see, we briefly mentioned, but this is the maximum multiplier is always 2. So whichever it's configured to always be 2, and whichever product a given user has purchased most frequently and most recently will be given the maximum of 2. There's also a less frequent and less recent purchase here, which was given a multiplier of 1.18. Again, if it were a multiplier of just 1, meaning no impact, well, then it would not influence the ranking of a given product. So products that have not been purchased are not influenced. Products that have been purchased are boosted up. And what if this user searched for something like fillet steak? Again, would this still be the first result? That would probably be a bad experience. You don't want, just because they purchased something with the word steak, you don't want to boost it up if they've expressed a different intent. And you can see a fillet steak is not being impacted. Now, organic British fillet steak, that was purchased in the past. That's good that appears. The British sirloin steak has disappeared because British sirloin steak is not a good match for fillet steak. So Irish fillet steak, organic British beef fillet steak, British beef fillet steak. These are all good matches for that search. So the personalization is not messing up the results. Now, if we go back to the search for steak, we can see, these are the two that she purchased in the past. But how's that done? Well, we go into the debug panel. We can see that there are two purchase history matches. But where do those come from? Well, there's a query. So if we copy that for DevTools, and if we were to execute that, we can see that these are the two matches that are relevant to this search for steak. So what does that look like in the final query? Well, actually, I'll copy it in for Cabana DevTools. Oops, copy, because it's easier to see over here. But effectively, what we've done is we have added a multiplier. If it is the British sirloin steak, or if the result is the organic beef fillet steak, you can see the multiplier. So there's a 1. Well, it's 1. So the base is 1. If there's no additional multipliers, just multiply by 1. Effectively do nothing to the score. But if it matches, then add 1 to that. So 2. That's where the 2 multiplier came from. And over here, we can see a 0.18, which means 1 plus 0.18, which is 1.18. If we go back to the results, you'll see that's exactly the multiplier that has been used to boost up this purchase history, or this product that was purchased in the past. So how much time does this add into the query critical path? Well, up here, this is a breakdown of the latency. This is based on timers that are put into the code. So I know exactly how much time from my browser, and I'm connecting to a server that's in the US. So most of the latency in this response is actually network latency, just from my browser to PRISM. And PRISM Studio latency is here. And the PRISM engine, by the way, PRISM Studio would be, is replacing, in this case, the customer application server. So this is not additional latency. The only additional latency that a customer would incur is this one here, 14 milliseconds. And most of that is the round trip overhead between PRISM engine and the Elasticsearch cluster. So if they're co-located, it might even be less than that. If I were to reload and look at that again, I might get different latency. Well, this time I went up 23. Let's try again. So 13 milliseconds. Most of that is, again, round trip. We can ping the Elasticsearch cluster, and in fact, we can strip out the ping latency from these numbers to see what, how much is PRISM itself actually adding to the overall latency. Usually it's somewhere between 5 and 20 milliseconds. If you're interested in learning more about how you can apply these personalization boosts, this is covered in detail on my blog, alexmarquardt.com, personalizing e-commerce search results based on purchase history. And I go into the calculations of how those boosts can be applied in a way that they don't overwhelm the intent of the original user query, but at the same time that they influence the ranking. So thanks for watching.